not the word prime, because you were able to do something. Okay. All right. So a variation of this, example, 2x squared plus 16xy plus 32y squared. Where do you start? Okay. There may or may not be one, but if there is one, you must remove it first. Is there a numerical GCF, a variable GCF, or a combination? Definitely numerical, right? What's the numerical? 2. Yeah, it's always the smallest one or smaller. Yeah. Is there a variable? Now, got an x squared, xy, and a y squared. None of them share. They don't share anything. Okay. So I'm going to pull the 2 out. You pull out a GCF, immediately put up a parenthesis, divide out for what's left. Now, as what's left is quadratic in form. Is it a quadratic trinomial?
Yes.
Well, it is degree 2, but remember here we have an x squared, an x, and a constant.
Is it because of the y squared?
Yeah. But let's look at a pattern that happens here. We have an x squared and an x, right? Yeah. And from the right-hand side, we have a y squared and a y. Yeah. So it's like quadratic x's from the left and quadratic y's from the right. Okay. Which actually is a pattern that we can factor. Okay. Think of it like this. If you have x and x, okay, so that x times x, and let's know where, yeah, so that x times x gives us x squared, right? Now on the back end, normally we just have 2 numbers, so we're going to have a constant on the end. But on the back end, what do we have here? So how are we going to get y squared on the back end? Yeah, y times y. Now imagine this. We've got x times x for the foil, f and foil, on the front end, and we've got y times y for L and foil on the back end. X squared, y squared. But what about the middle? Well, middle of foil is O plus I. Something xy plus something xy gives us something xy. So you're looking for, in this case, your x does not have a coefficient, so it'll just be naked x's. But here, when you find your 2 numbers, they're not just 2 constants, k1 and k2, but they're coefficients of the y's. Okay? So x squared plus xy plus y squared. Yeah. So this is of a form, basically, ax squared plus bxy plus cy squared. Okay? Which is still quadratic. It's just instead of just x's plus or minus numbers, you have x's plus or minus something y.
So it's going to be plus or minus something, right?
Yes, it's still the same sign pattern rules and number crunching. Crunching your ACB and figuring out your sign pattern is still all the same skills. You just, when you write your final answer, you're going to have x and y's in both of them. Okay? So I'm going to cross that out so I don't get my ACBs mixed up. My 2 is part of my final answer. Okay? In fact, I might even write 2, and I know I'm going to have this, and because my x is a equal 1, so I know my x's are naked. What's my sign pattern?
It's positive.
Positive, yeah. You've got a positive c, so it's either 2 pluses or 2 minuses to get that positive product. And because the middle, the O plus I is positive, then that means everything's positive.
Oh, so the x and the y that was in the middle, that's automatically positive? Well, it is.
If this is plus. So if your C is positive, then you know that the only way you get a positive product, your L and foil, multiplying your last things, the only way you get positive is 2 pluses or 2 minuses. So the middle term is going to tell you which it is. A plus plus a plus gives you a plus in the middle. A minus plus a minus gives you a minus in the middle.
Oh, okay.
So positive C, 2 pluses or 2 minuses, the middle term will tell you which it is. Plus and plus, and then I leave some room. I've got y's, but I'm trying to find their coefficients. Yeah. Right. So AC and B. This is another thing, right? Yeah. So your AC is 16 and your B is 8. And so your magic pair of numbers, if they're more positive, you found is 4 and 4, right? They match. What this was, when they match like that, your binomials match. That means something times itself means it is squared. So x plus 4y squared is the proper way to write it. And don't forget, we do have a 2 in front for our GCF. Okay.
So if we would have left it like that, would you kill it wrong?
I want it to be written in the squared form. Yeah. Yeah. I mean, it'd be most a point off, but yeah, I want you to get in this habit, because we're going to come back to this in a minute, because there are ways to recognize this before you do all the work. That shortcut of recognizing this is what's called a perfect square trinomial. Okay? And when you recognize a perfect square trinomial, you don't have to do all the number crunching. Okay? Now, it's no big deal if a equals 1. Most of the time I miss it. Myself, I miss it's a perfect square when a equals 1, because I'm not thinking, it's easy enough to crunch the numbers mentally usually. But when we get into really big numbers and a is not equal to 1, you're going to save yourself a lot of work, a lot of tedium, by just going straight to the answer. Okay? Which, if you recognize it's a perfect square trinomial, you can go straight to the binomial squared. Okay? So we'll come back to that. Okay.
You can also recognize it from the first one, right? From the original.
From the original up here? Not really, not without the GCF out, because you recognize it by seeing that the first and the last terms are perfect squares.
Okay.
So 1x squared and 16y squared, those are both perfect squares. Those are not perfect squares, so it's, yeah. That's another reason why GCF being pulled out first is key. Yeah, you can't make other decisions as there's a GCF, yeah. Okay. So 6x squared plus, hold on, let me see. Let me come back to that one in a sec. Okay. So let's do 3x squared plus 14x plus 15. Okay, so GCF. Nope. No. No, it just means that your A is not equal to 1. You weren't able to pull out GCF. Your A is still not equal to 1. We don't know if it's prime yet or not until we find the magic pair of numbers. Now here's the thing though. Everything we've done so far has been A equal 1. Even if it didn't look like A equal 1, there was a GCF, and then it was A equal 1. Okay? But here, A is not equal to 1, and there's no GCF, so A is not equal to 1. So here's the bad news. The A not equal to 1 trinomials are probably the most tedious to graph. Okay, I get bored with them. Okay, just a skill you have to have. The more efficient you get at it, the quicker it goes, the better. The good news is that you already have all the skills you need to factor this. Okay? You're going to still crunch your numbers the same way. It's just that then you're going to have a second step. But the second step is already something you know how to do. It's what we did in 9.1. It's 4-term grouping.
You're multiplying with 3x times 15.
Right, that will be your AC. Now, since your A is no longer 1, it's still, but that's why I was using AC, even when A is 1, because nothing changes. It's still ACB. So the first step you're going to do is crunch your numbers. So find your AC and find your B. Okay. But now your AC is not 1, so you actually, instead of 1 times 15, you got 3 times 15. AC is just multiplying A times C. And so your AC is, and your B. Okay? So crunching the same numbers. Just A isn't 1, so you have to do that multiplication. Move it up here. AC is 45 and B is 14. What's your sign pattern in this one? Yeah, both positive. Positive C and positive, yeah, all positive. So those are going to be positive numbers. Okay. Okay. So, yep, 9 and 5. Yeah. So we got 5 times 9 or 9. It doesn't matter the order. Yep. Now, here's the thing. So hold that thought. is not 1, then you are not done. All right. If A is not 1, you are not done. This is not equal to. This is not x plus 5 times x plus 9. If A were equal to 1, sure, it would be. You'd be done. Those are your magic numbers. Plug them in.
But you pull it 3 out, right?
Right. Well, no, those 3 didn't get pulled out. It's not a GCF. We had to work with it. It is our A, and there's our B. A is 3 times 15, B is 14. And so you crunch the numbers just like you do when A is 1. First step, same thing you're doing, A, C, B. But look, if you just say, oh, okay, I'm done now, I found my magic pair of numbers, x plus 5, x plus 9, what happens when you FOIL this?
You get A squared
And does that match? No, because you had naked x's. There's no coefficient of your x squared term. This doesn't match. It can't be right.
Oh, so you have to do 3x. Oh, wait.
Ah, yeah. So there's a second step, okay? So let's look at what that second step is. So if A is not 1, you're not done. You do the same first step. You crunch your numbers, and these are your magic pair of numbers. Now, if for A not equal to 1, your first step, step 1, is your your x, okay, or your ACB. Okay, you crunch your numbers exactly the same way. Same step as the other one. If A is 1, then that's it, you're done. Okay? But if A is not 1, you have a second step. And the second step is split your middle term. I'll show you. Yeah, not in half. These magic pair numbers tell us how to split it. So you split your middle term, and then you use 4-term grouping, which you already know how to do from last time, 9.1. Okay. So if A is not equal to 1, that's just the first step. If A were equal to 1, that's it, you're done. If it's not, you have to do the second step. So look at your middle term. What is the variable of this middle term? X. So put an X here. Okay. Because we're not just using 5 and 9, we see that doesn't work.
Oh, so now when you plug it in, it's gonna work.
Well, not yet. We have to do this whole, we have to split and group. So we're going to rewrite our trinomial, and there's a lot of ways we could split 14 up. 1 plus 13, 2 plus 12. Yeah, but in all combinations of negative numbers or decimals or fractions, I mean, there's an infinite number of ways you can add 2 things to get 14. How are we going to add them? Use the 5 and the 9. Out of all the infinite choices, our ACB told us the 2 that we need. Rewrite your trinomial, 3x squared, but you're going to split your middle term. Okay? Plus 5x, plus 9x, and then plus 15. Okay? Do a real quick check. You didn't change the value of your trinomial. You just changed the middle term into 2 terms that still equal 14x. Huh? Huh? And now you can do 4-term grouping. Okay? So I'll write this out. So 3x squared plus 5x plus 9x plus 15. Make sure there's that plus in the middle. Remember, that matters. We'll have an example where that's not the case. Okay? The order doesn't matter. You could have written 9x first and 5x second. It does not matter as long as it adds up to 14. The order doesn't matter, though you may want to make a choice. If you have mixed signs, you can make a choice that will make your grouping easier. Okay, little GCF, little GCF. Big GCF.
Okay, so first you got rid of the variables, and then you got rid of the 3. Does it matter if you do either or it would matter?
Yeah, then this is the four-term grouping method, so we can go over this more after, because this was from last time, okay? But it's also from 308. The four-term grouping means that we can't factor this whole thing, but we can factor the first group has a GCF of x, and the second group has a GCF of 3. So we factor the x out of the first group and the 3 out of the second group. Now once we do that, we see we went from four-term sum to a two-term sum. 1, 2, 3, 4 terms here. Little GCF gave us a two-term sum. Here's one term, here's a second term. And they have something in common. We divide out, we GCF out the 3x plus 5. And when that cancels out of each of those, that's our GCF. And what's left is x in the first term plus 3 in the second term. And there's our two binomials. Now we can FOIL 3x times x, 3x squared. 9x plus 5x, 14x. And positive 15. So if A is not 1, then your first step is the same as when A is 1. Do your ACB, crunch the numbers. Okay. And if A were 1, then that's it. Those two numbers are your two numbers, x plus and x minus. Okay. But if A is not 1, you have one more step. Just use that magic pair of numbers. Now, it's always important. Always check your middle term. Because in this case, the middle term is x, but sometimes it's y, or m, or xy. And if you don't put the correct variable, then when you do your four-term grouping, it's going to be it won't make sense. Okay. So our middle term is x. Our magic numbers get that x, because now those magic numbers are actually the split middle. These right here, because A is not equal to 1, so because A is not equal to 1, that means because A is not equal to 1, then this right here is our split middle. And that split middle changes our trinomial to a four-term without changing its value.
And like you said, if 14, like B is xy, then over here, put 5xy and 9xy.
Exactly. Whatever this middle variable, because this has to add up, that's why you do a little check here. If this was a y and you put 5x and 9x, it's like, wait, 5x plus 9x is not 14y. Okay? So that's another little check there. When you add these up, like terms, they have to equal whatever that variable is. It's another little check as you go. Okay, so try this. Okay? All right. So do 4x squared minus 39x plus 27. GCF. No GCF in there. If there were GCF, it would have to be 4 or smaller. So either 4 or 2, and that doesn't work. And there's no variables in common. So crunch your numbers. It's definitely one I use my calculator for.
Oh, it's because you multiplied that 4.
Yes, AC just means A times C, 4 times 27. Those are some big numbers. This is exactly where the calculator is most useful and efficient. My AC is 108 divided by X. And I want to find factor pairs of 108. My factor pairs meaning two numbers that multiply to make 108. And then my last column is going to sum them because they also have to add up to negative 39. Okay. And I'm looking for negative 39. So I look in my last column, my B, my sum column. I'm going to go up to get to the negatives. And so there's my factor pair. And I also noted, I see it there, but also if I noted in advance, I'm going to have two negatives because I got a positive C. So it's two pluses or two minuses. And the middle term tells me that it is two minuses. Because minus times minus gives me positive 27, but a minus plus minus, O plus I, minus plus minus is a negative B. And it is 3 and 36. Okay. Now remember, if A is not 1, you are not done. You have a second step. This is your split middle. What is your middle variable? Middle variable. Yeah, just an X. Right. So this is your split middle. Now they're both negative, so it doesn't matter which one you use first. This is what you have to be careful about with the four-term grouping. Remember, 4x squared. Let's do minus 3x minus 36x plus 27. Do a quick check that negative 3x plus negative 36x, yes, equals check, negative 39x. I didn't change the value of my trinomial. Okay. I just turned it into a four-term in a fair way using my ACB crunch. Okay. Now, what's the problem, though, here? Four-term grouping, we've got subtraction in the middle. What do we have to do? Yeah. Change it to plus, a minus. Yeah, plus a negative. Because otherwise, if we just put our group up right here, then that means that if we put parentheses here, that negative belongs to the 36x, but it also belongs to the 27. It would change positive 27 to negative 27. It's an illegal move to just put up parentheses with a subtraction in the middle. Because parentheses all of a sudden means that subtraction belongs to both those things, and that would make this negative and change its value. Okay? So change this to 4x squared minus 3x plus negative 36x.
So you can just, by rule, you just can change it on your own, right?
Yes, because that's what subtraction means. Subtraction means adding the opposite, or subtraction means adding a negative. Okay? Subtraction means move left on the number line. Adding a negative means move left on the number line. These have the same meaning. But by doing that, keeping that plus in the middle, that means when you throw your parentheses up around your two groups, and I was writing it separately so we can see the progression. When you put your parentheses around your two groups, if there's a plus in the middle, then that means this is still negative 36x, check, and this is still positive 27, check. If you put two groups up with that negative there, then that makes this negative 36, negative 27. Because parentheses mean distribute anything that's in front of it. This is just distributing positive 1, doesn't change anything. It keeps this negative and it keeps that positive. Okay. All right, ready to little GCF, little GCF. Now when you make that sign change, what do you know about your second GCF? What is the GCF of 36 and 27?
No.
That's a CF, but not the GCF.
9.
9, yeah. So, do I use 9?
You did.
If I made that sign switch, what do I know about my second GCF?
It's going to be
Negative.
Negative, yeah. Otherwise, you're going to end up getting binomials, leftover binomials that don't match. They'll be opposites. If you just pull out a positive 9, here you pull out an X, and I'm left with 4X minus 3. Okay? Now, if I just pull out a 9, what am I going to be left with here? Negative 4x. It's not going to match. Okay? So if you make this sign flip, then that means your second GCF must be negative. Always. Yeah. If you have to make a sign flip when you're four-term grouping, if you have to change from subtraction to plus a negative, that's fine. But in order to keep your binomials matching, you have to pull out a negative GCF. Otherwise, you pull out a positive GCF. And the other clue is if you've got a leading negative, generally you want to pull out a negative GCF anyway. The greatest common factor is 9. You want to pull out the negative. Now, when you pull out the negative version of it, you can just, now it's okay to write it as subtraction. Okay? Plus a negative 9, just write minus 9. That's not a problem now. Leaving you behind with a positive 4x minus 3, and they match. Okay. Now, I'll write this out the long way just to make sure everybody's clear on this next step. I do my little double line and squiggle as kind of as my quick way of writing. But basically, this is big GCF. These are two terms. We went from 4 terms to 2 terms, and they share a 4x minus 3 in common. Right? So that means my GCF is 4x minus 3. You always pull it out and boom, put up another parenthesis. And those divide out, leaving behind x and then minus 9. And that is your factored form.
Does it matter what order you put it in?
No. What is 3 times 5? And what is 5 times 3? They're both 15. Order of subtraction, order of multiplication does not matter. Yeah. So if you like to put the squiggly ones out, the outside ones first, see, when you factor either way, FOIL, either way to check, it's going to be the same. So 4x squared, check. Negative 36 plus negative 3x, negative 39x, check. And positive 27, check.
That's what I figured. But
Yeah. Yeah, no, that's a common question. No problem. It's just, that's something to just think about. Because the thing is, when we're factoring polynomials, we want to keep sight of the fact that the basic rules, the basic mathematical understanding is the same as when we're just factoring regular numbers. Okay? Factors of 15 are 3 times 5. The factors of this polynomial are this binomial times this binomial. Okay? The idea is that a factor times a factor equals that big thing, or these will divide into that big thing. Just like 3 or 5 will divide into 15. Factors and divisors it's all connected, whether you're doing just numbers or whether you're doing polynomials. Yeah. So those same mathematical rules about like order of multiplication are still the same rules. Yeah, that's an important concept to have. It's good. Okay. So 16x squared plus 6xy minus 27y squared. I'm also going to put one other up here, so if you finish that one, you can jump down to one last one. Then we're going to move to a new technique. Let's do also 6x squared plus 13x plus 8. That's a separate problem. Okay. Where do you start? How do you know when you're done? If A is not equal to 1, it takes 2 steps. So you do that first step, and remember, if A is not equal to 1, you are not done. Split your middle in that case. There's some big, ugly numbers on that one. I think before you crunch those numbers, either mentally or in your calculator, what's your sign pattern? Helps you check as you go. 2 pluses, 2 minuses, or a mix. With a negative 27y squared on the end. 2 pluses, 2 minuses, or a mix. Yeah. The only way you can get a negative L or a negative C, it's a product. You're multiplying the last two things when you